Now in this video lecture we will go through some of the properties of colloidal solutions. We will go through electrophoresis, electro osmosis, and then your then your Brownian movement, because colloidal particles do show Brownian movement. First is your electrophoresis, right? Then is your electro osmosis, is your Brownian movement. Brownian movement. So we'll go through all these three one by one. These first two processes, electrophoresis, electro osmosis. It involves the word electro, that means electricity would be involved in both these processes, right? Like we did in electrochemistry, right? Electricity was involved in chemical reaction, so it was electrochemistry. So here electro osmosis, so in the process of osmosis electricity would be involved, right? So now both these processes, electrophoresis and electroosmosis, is based on the charges, right, that is present in colloidal solutions, right? So all right, electrophoresis, right, and your electroosmosis, right, both these are based on charges, right, present in salts or colloidal solutions, right? Now to understand these processes, let's understand the charges that are there in colloidal solutions, right? And we have done this in the previous lecture where we understood the stability of colloidal solutions, right, or the how charges are present in colloidal solutions, right? Let's just quickly briefly understand that again. In the previous video lecture we have understood the preparation of silver iodide, which is a colloidal solution, and we said it is prepared from silver nitrate and potassium iodide, right? Silver iodide is formed, right? Suppose this is the colloidal particle of silver iodide. Right, now I can take either of these two reactants in slight excess, right? Slight excess means in small quantity. I'll just increase, if I increase this quantity of potassium iodide slightly, right, then it is the property of colloidal particles that it will absorb, that is silver iodide will absorb one of the common ions, right, from this electrolyte, right? Potassium iodide is an electrolyte, so silver iodide will absorb the common ion from the electrolyte which is used in excess, right? So here we use excess of slight excess, I'll write slight excess of potassium iodide, right? So silver iodide, right, which is a colloidal particle now, will absorb the common ion from the electrolyte, right? And here the common ion between silver iodide and potassium iodide is iodide ion, right? So iodide is the common ion, right? So this silver iodide will absorb iodide ion, and we know that iodide ion has a negative charge on it, right? So this potassium has a positive charge, iodide has a negative charge in the electrolyte potassium iodide. So this silver iodide will absorb iodide ion and thereby will acquire negative charge, right? Silver iodide will absorb iodide ion onto its surface, thereby acquiring a negative charge, right? Now since this silver iodide, which is a colloidal particle, is in dispersion medium, right? This is a colloidal solution. Silver iodide is a colloidal particle which is a dispersed phase, right? So it's in a dispersion medium, right? Now from this electrolyte, iodide ion is adsorbed by silver iodide. What about potassium ion, which is a positive ion? It will remain in the dispersion medium, right? So potassium, which are positive ion, will remain in the dispersion medium, right? Potassium, let's first write, silver iodide will acquire negative charge, right? And potassium ion from this electrolyte will stay in dispersion medium, right? Since potassium has a positive charge on it, right, so it will give positive charge to the dispersion medium, right? It will stay in dispersion medium, making it positively charged, right? So now colloidal particles, which is a dispersed phase, is positively charged, right? Colloidal particles are positively charged, right? Colloidal particles are negatively charged, as we studied here, due to adsorption of iodide ions, right? And your dispersion medium is positively charged, right? This is due to iodide ions, right? And this is due to potassium ions, right? So now we are clear about the charges that are present on the colloidal solution, right? In the same way, every colloidal solution will acquire a positive and a negative charge. One charge is on colloidal particles, the equal and opposite charge would be there in the dispersion medium, right? So colloidal solution as a whole would be neutral, because negative charge on colloidal particles would be equal and opposite to the positive charge on in the dispersion medium, right? So we say Sol, or the colloidal solution, Sol is electrically neutral, right? Sol is electrically neutral. Now let's understand one thing, that here I have taken this electrolyte, potassium iodide, in excess. If I would have taken silver nitrate in excess, right, then the common ion between silver iodide and silver nitrate is silver ion, right? And we know silver ion is positively charged. So if we use silver nitrate in slight excess, colloidal particles will have positive charge due to silver ions, and due to nitrate ions, which will remain in dispersion medium will have negative charge, right? So if we use silver nitrate in excess, colloidal particles will have positive charge, dispersion medium will have equal and opposite negative charge, and Sol would be electrically neutral. Now let's come to electrophoresis, right? Electrophoresis is the movement of colloidal particles in colloidal solution under the influence of electric current, right, or under the influence of electricity, is your electrophoresis, right? So if I take this U-tube kind of a thing, you can see these diagrams in your books as well, right? This is a U-tube, right? And I have taken this solution, colloidal solution, in this U-tube, right? And this U-tube, we have two plates, right, in this, and these are connected to the positive and negative charges of a, say, battery, right? Because we are applying electric current, right, to this U-tube that has a colloidal solution in it, right? So let's just represent the colloidal particles with the red color, right? And this is, say, these are colloidal particles, right? Suppose I move this silver iodide only in this U tube and apply electric current, we know that silver iodide is your has a negative charge. If I'm using potassium iodide is in excess, right? So here silver iodide will have negative charge, right? And your dispersion medium will have positive charge, right? So what will happen, since silver iodide has positive charge, right, and we have this plate is connected to the negative terminal, so this is your cathode, right, and this is connected to the negative positive terminal, so this is your anode, right? And we know that positive ions will move towards anode, right? So the silver iodide colloidal particles, right, will all move towards positive plate, right, positive electrode, which is your anode, right? Because silver iodide has negative charge on it, right? Since it has negative charge on it, so when electric current would be applied, it will move towards anode, right, which is positive electrode, right? So in it, all these colloidal particles, these silver iodide particles will move and will assemble near, these are silver iodide negatively charged particles, and this is your positive electrode, which is anode, right? So here, under the influence of electric current, these colloidal particles, negative colloidal particles, are moving towards positive electrode, right, which is your anode, right? So this movement, right, since these particles are moving towards electrode, right, so we call this process as electrophoresis, right? So electrophoresis is the movement of colloidal particles towards the respective electrode, right, under the influence of electric current, right? So this is how we will define it. The movement of colloidal particles under the influence of an electric current is your electrophoresis. So here, movement of colloidal particles. Which are colloidal particles here? These. Silver iodide. Movement of colloidal particles. And when it started moving? When we applied electric current. Under the influence of electric current, right, is your electrophoresis, right? This process is your electrophoresis. Since in the beginning, when these experiments were conducted, most of the solutions, colloidal solutions that were taken, have positively charged colloidal particles in it, right? So we know that if instead of silver iodide is positively charged, when we take silver nitrate is in excess, then positively charged colloidal particles will move towards cathode, right? Since these are positively charged and cathode is negative electrode, right? So these will positively charged colloidal particles will move towards negative electrode, which is cathode, right? So this process is also known by the name of cataphoresis, right? Cataphoresis. Right? Cataphoresis, because cata is taken from cathode, right? And why we call it cataphoresis? Because earlier, when these experiments were conducted, most of the solutions that were taken were positively charged, right? Or the colloidal particles in those solutions were positively charged, which moved towards cathode, right? So this process was also known as cataphoresis, right? So I hope this is clear to you. And electrophoresis, why do we call it electrophoresis? Because later the experiments were conducted with the negatively charged colloidal particles as well, which moved towards anode, right? So now it was known that the colloidal particles can move towards either of the electrode, cathode or anode. So they are moving towards electrode, so we call it as electrophoresis. We call this process as electrophoresis, and the application of this process is that it will tell us the nature of the colloidal solution, right? Whether it is negatively charged or positively charged, right? So electrophoresis tells us whether the colloidal particles are negatively or positively charged. This is the application of electrophoresis. Electrophoresis will tell us or indicate whether the particles are colloidal particles basically are positively charged or negatively charged, right? If particles will move towards cathode, these are positively charged. If they move towards anode, they are negatively charged, right? Now let's understand the second process, electroosmosis. Electroosmosis, here in this process we have seen the movement of colloidal particles, which is dispersed phase. So here the dispersed phase is moving under the influence of electric current. In electroosmosis, dispersion medium will flow. Dispersion medium will start moving under the influence of electric current, right? Because we have seen here that even the dispersion medium has a charge which is equal and opposite to that of dispersed phase, right? So electroosmosis is movement of dispersion medium, right, under the influence of electric current. Right, under the influence of electric current. Now we'll again draw a simple diagram, right, like this, right? And from here we will fill the colloidal solution, right, that we would be working with, right? From here we can fill it, and there is one condition: when the dispersion medium is moving under the influence of electric current, we will not allow dispersed phase to move or the colloidal particles to move, right? Here dispersed phase or colloidal particles are not allowed to move. Right? Dispersed particles and colloidal particles or dispersed particles would not be allowed to move. It's only the dispersion medium that will move under the influence of electric current. So we'll see how we can stop these colloidal particles to move, right? What we will do is we will take a semi-permeable membrane. We will take a back kind of a thing, which is a semi-permeable membrane, right? And inside this semi-permeable membrane, we will take the colloidal solution, right? We will take the colloidal solution, and this is your SPM, semi-permeable membrane, right? And you have the water outside of it, right? And we said that we would be applying an electric current, right? So this is how we would be applying an electric current to it, right? This is your negatively charged, this is your positive charged plate, right? So when electric current would be applied, right, since this is a semi-permeable membrane, it will not allow colloidal particles to move. Why? Because semi-permeable membrane has very small pores, right, smaller than the colloidal particles. So it will not allow colloidal particles to move, it will only allow dispersion medium to move, right. So if say dispersion medium is positively charged, right, say we have these positive potassium ions, if we take the same here, if we transfer the same colloidal solution here, the potassium, the dispersion medium is positively charged due to these potassium ions, right. So we have positive charge on the dispersion medium, right. So here dispersion medium has positive charge. So when you apply electric current, these positive charge dispersion medium will start moving out towards the negative plate. Since dispersion medium is positively charged, so it will move towards cathode, right. So these will move towards cathode under the influence of electric current. So here, if you look at this, this is osmosis which is taking place. This is the process of osmosis, where liquid is moving, right, from higher concentration to lower concentration, which is outside we have water, right. We have studied this in solutions, the process of osmosis, right, where liquid is diffusing through, or dispersion medium in this case is diffusing through your semi-permeable membrane, and this process is known as osmosis, right. And if this is conducted under the influence of electric current, because here the liquid is, this dispersion medium is moving under the influence of this electric current, so we call it as electro osmosis, right. This process, the movement, I'll repeat, the movement of dispersion medium through this semi-permeable membrane, right, is your osmosis. And since it is done or conducted under the influence of electric current, this is known as your electro osmosis, right. So I hope this is clear to you. So this is a phenomena in which molecules of the dispersion medium are allowed to move under the influence of electric field, right, whereas colloidal particles are not allowed to move using this semi-permeable membrane. This is your electro osmosis, right. I hope both these are clear to you. Just remember this concept and this would be easy for you, right. Now we have Brownian motion, Brownian movement. This is also one of the properties of colloidal solutions. Brownian movement, we have studied this in our small classes, right, in our junior classes, right. Brownian motion, let's recall what it is. If you remember, Robert Brown, the scientist named was Robert Brown, who first noticed this phenomena happening, right, in solutions. What he did, he took pollen grains, right, pollen grains and put it in water, and he observed the pollen grains under microscope, right. So what he noticed, that the particles of pollen grains were moving in a zigzag random fashion like this, right. It is moving like this, if you will, like this, right. So this type of movement is this zigzag movement of these pollen grains, right, is termed as Brownian movement, right. Why Brownian? This is from the name of the scientist Brown, who first noticed it, right. So we call it as Brownian movement, right. So Brownian movement is the continuous zigzag movement of these pollen grains, right, which he noticed the first time. So this is your Brownian movement. Now let's see if we can observe the same in your colloidal solution, right. So if you take colloidal solution, right, right, and if you observe if you take a colloidal solution, right, and if you observe the colloidal solution in this ultra microscope, you will see that these colloidal particles also move in the same way, like Robert Brown observed how pollen grains were moving, right. So we say that colloidal solutions also follow or also observe this Brownian movement, right? So colloidal solutions, in the colloidal particles also move in the same zigzag fashion, right? So we say that the colloidal particles undergo Brownian movement, right? So when viewed under ultra microscope, colloidal particles are seen continuously moving in zigzag way, right? So this continuous zigzag movement of colloidal particles in a colloidal sol is your Brownian movement, right? So if you will see this in electron microscope, you will see that it's moving like this, then it goes like this, then it goes like this, then it goes like this. This is your zigzag movement of colloidal particles when seen under electron microscope, right? So what is the cause of Brownian movement? To understand this, what could be the cause of Brownian movement? Cause is, since the dispersion medium molecules are also there in the colloidal solution, right? And this colloidal solution, the dispersion medium, the molecules of dispersion medium will continuously strike with the colloidal particles from all directions, right? Now these colloidal particles will continuously keep moving, right, due to the resultant force which is acted upon by the molecules of dispersion medium, right? We have dispersion medium here, right, and we have colloidal particles, right? Suppose this is the colloidal particle, let's say, and dispersion medium will keep striking, right? Dispersion medium will keep striking this colloidal particles from all directions. These are dispersion medium molecules, right? So dispersion medium molecules are striking these colloidal particles from all directions, and due to this striking by dispersion medium molecules, this colloidal particle will move in the direction due to the resultant force, right? So it will move in this direction. Since resultant force is acting in this direction, so it will move in this direction. The resultant force would be in this direction. So all colloidal particles will undergo the same behavior, where the molecules of dispersion medium will strike the colloidal particles, and it will keep moving in the zigzag random fashion, right? And it is due to Brownian movement, right, that these colloidal particles will remain suspended, right? They will not be settling down, right, because dispersion medium will continuously strike it, and they will keep moving in the colloidal solution. So they do not settle down or precipitate or coagulate due to this Brownian movement, right? Now we have some more thing in Brownian. What is the cause of Brownian movement? This resultant force is the cause of Brownian movement, right? We have done this. Now what is the importance of Brownian movement? The force of gravity, the Brownian movement, as I said, the Brownian movement, since due to Brownian movement these particles are moving, right? So it opposes the force of gravity. These colloidal particles will not settle down under gravity. They will keep moving like in this zigzag fashion, right? So Brownian movement, right, this is responsible for the stability of colloidal solution. That's what we say. Its importance is that it is responsible for stability. It is responsible for the stability of colloidal solutions, right? And earlier we have already understood that these charges are also responsible for the stability of colloidal solution, because due to this charge the colloidal particles will not unite, will experience a repulsive force, right, due to which they will not unite to form bigger particles and settle down, right? And here it's as per Brownian movement, these particles will keep moving in a zigzag fashion because they will keep experiencing force from dispersion medium molecules, right? So due to this they will not settle down, they will keep moving randomly, scattered and suspended in the solution, right? So I hope all this is clear to you, right? So we have understood three things here: electrophoresis, electroosmosis, and Brownian movement. Thanks.